I'm Bob Mackey. I work for a company called Synaptics that makes touch sensors. I'm the director of biometrics research, or the principal scientist. For fun, I build vehicles, airplanes, cars, trains, and electrify some of those. And I'm looking forward to electrifying the train in particular using some of these batteries.
One of my goals here is to not spear a lithium cell into the forklift.
What is the best way to grab the pack when you pull it out of this box?
I just grab them by these tabs on the end. You don't want to grab all the way down the side, that's where the high voltage electrode is. But you can grab them right here by these hooks, and this is where they're supported in the modules. These keep the packs separate from each other so they don't touch each other.
So they don't touch each other, and
yeah, with the BMS on, these electrodes are protected. But without the BMS, those are exposed. Many of these did not have a BMS on them when they were received. If one electrode on this pack touched one electrode on that pack, it would be okay. If two electrodes on this pack touched two electrodes on that pack, it could be an instant fire.
you'd have thermal runaway.
Or first, the flash might blind you, and then you wouldn't be able to see where the fire extinguisher was, or find where the controls are on the forklift to drive it out in the parking lot and dump it. So don't do that. The first thing we did is we're going to check the voltage across the whole thing.
With the BMS still attached, you're putting your probes on the electrode with the black wire and the electrode with the red wire. And that's to test the voltage.
So they're insulated on the very top, but right there on the sides, there's bare nickel where you can...
So you got to get underneath that paint, and you can see the exposed
right there.
Electrode underneath.
And on the other ones, you can contact them right there. Or on the side of that screw. 36.3 plus 36.3. Okay. Now, that's a quick estimate of the health of the whole pack.
Right.
From that, we could figure out that each cell is, if all the cells were the same, there's 12 in series, and we got 36.3 volts. 36.3 divided by 12 is 3.25. And 3.25 is not bad.
It's not bad.
Not bad.
It's a little on the low side.
But that's not the whole story.
That's not the whole story, because we got to look at each individual group.
Here, I'm going to make this a little more sensitive. Give it two significant digits. .24, 3.29, 3.30, 3.29, 0. 0. That's not a good sign. Okay, keep going. Hold on. 3.29. 3.29. 3.29, 3.30, 3.29, 3.30, 3.3, 3.3. That's it. So all of them are 3.29 to 3.30, except this one. That tells us there's a dead short cell in this group. One of the 8 cells in that group is dead, and it killed the other 7. So, guaranteed, all 8 of those are trash. You won't recover the cells that have been pulled down to 0 volts. So, for tearing apart, this is a good pack to tear apart. The current would have gone through good batteries, and now it's going through bad batteries.
Okay.
It may be going around those batteries through a piece of metal, or it may be all going through one of the batteries that has the short in it. We don't know. Now, I want to know, is this an open circuit or a short circuit? The meter, as a voltmeter alone, can't tell an open circuit from a short circuit. Either way, it's the same voltage difference. So I switched to ohm meter mode. So we've already verified that there's 0 volts across it. Now measuring carefully across just this pack. Don't do this on any other high voltage or any circuit with voltage on it. If you put a higher voltage across it from the battery, a lot of current will flow through the meter and the meter will quit working. It will blow the fuse in the meter.
Or the current coming from the charged cell will overdrive, will destroy the meter.
Yeah.
So the only reason we can test this one group
is because it's dead and we know it's dead. We put that across there and it says 2 ohms, 2.4 ohms. But we also got 2.4 ohms when we did this.
So when you short the probes together, you get 2.4 ohms approximately.
Yeah.
And when you put the probes across that dead group, you get the same thing, 2.4 ohms.
So the 2.4 ohms, it's in these wires.
In other words, that group is not adding any additional resistance.
Right. That's right.
Why do we care? What does that mean that there's no resistance? If you put a load on this entire pack, that one bad group, which is in series with the other 11 groups,
It's just a wire.
is just a wire.
Yeah.
It acts like a wire, so basically it's as if you've got 11 groups in
It's as
series.
if I have a 36 volt battery instead of a 39 volt battery.
Then what are the drawbacks to using a pack that has a bad group, besides the lower voltage?
Well, we don't know why it's bad. If we discharge this one in series with that one, they get exactly the same current through them.
Yes.
So if this one has 2 amp hours and we drain it down to 0, then this one has to have minus 2 amp hours. Or it has to make heat, one or the other. If it stays shorted, it just generates heat. And because we don't know, we should cut this pack open and take out the bad cells.
Okay, so we do not recommend using a complete pack if it has a bad group.
Nah. Or if we did, I would actually put a wire from here to here and make sure they stay shorted.
So if you put a bypass wire from there to there, that will route
It would make
the pack.
it safe to use this pack. You couldn't put this pack in parallel with any other pack.
Because they'd have a different voltage.
The 40 volt pack would dump all its power into this 36 volt pack.
Right, because when you connect batteries in parallel, you want them to be at the same voltage.
Right. Oh look, here's one that has a useful label on it.
50%.
50%. Let's see what's happening in this 50% over here. It could mean that every single cell in here has half the capacity, or it could mean that one pack has half the capacity, or it could mean one cell has half the capacity.
When you said one pack, you meant one group.
Yeah, one group, one parallel group. Right. If one parallel group, if its voltage drops too soon, this whole thing with the battery, with the BMS, will shut down whenever any cell gets too low a voltage. If you can only, it says it's supposed to take 736 watt hours, but if it only delivered 368 watt hours before one of the cells shut down, then they would label it 50% if they meant 50% capacity. The most valuable thing to do would be to learn how these BMSs work and be able to communicate with them. And then we can just ask them, is this battery good? Got a microprocessor that decides what to do. And it has communication ports that talk to the module and tell the module, to either set off a red light because there's something wrong or keep working. Turn on the green light and keep going. So these have some mechanism for detecting failures. And if we could just turn it on and have all the red lights light up, that would be handy.
And if a pack came to us without a BMS, then we could use a loose BMS to test it.
Yeah. If we can communicate with one BMS, we're miles ahead of where we are.
Okay, so that'll be another separate video. For now, we're trying to determine the health of packs without a BMS.
Right.